According to the National Electrical Code, specifically Article 680.42, even if a house has only polyvinyl chloride, or PVC, water piping, the spot hub motor must be bonded to the electrical panel. The National Electrical Code mandates that all exposed metal parts of electrical equipment, and this includes the spot hub motor, be bonded to the electrical grounding system. This requirement is in place to significantly reduce the risk of electrical shock in the event of a ground fault. In situations where a house is plumbed exclusively with PVC water piping, there is no inherent electrical grounding system available through the water pipes themselves. Therefore, it becomes crucial to establish a direct bonding connection between the spot hub motor and the electrical panel, utilizing a dedicated bonding conductor. The size of this bonding conductor must be determined in accordance with the National Electrical Code Table 250.122. For a typical spot hub motor, the bonding conductor is required to be at least an 8 American wire gauge copper wire. The connection of the bonding conductor to the spot hub motor must be accomplished using a bonding lug or another approved method that ensures a secure and reliable electrical connection. The bonding conductor must then be routed to the electrical panel and securely connected to the grounding busbar within the panel. It is very important to be aware that local electrical codes may have additional or more stringent requirements for the bonding of spot hub motors. Because of this, it is always recommended to consult with your local code official to ascertain the specific requirements that are applicable in your particular area. This will ensure full compliance with all applicable regulations and help guarantee the electrical safety of the spot hub installation. In addition to the specific requirement for bonding spot hub motors, it is important to understand the general principles of electrical grounding and bonding. Grounding refers to the connection of electrical equipment to the earth, while bonding refers to the connection of different metal parts of the electrical system together. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source, which will cause the circuit breaker to trip and to energize the circuit. The purpose of bonding is to equalize the voltage between different metal parts of the electrical system, which will reduce the risk of electrical shock. The National Electrical Code contains detailed requirements for grounding and bonding, and it is important to follow these requirements carefully to ensure the safety of the electrical system. In addition to the requirements in Article 680.42, there are other sections of the National Electrical Code that may be relevant to the installation of a spot hub. For example, Article 680.26 covers the requirements for equipotential bonding of metal parts in the vicinity of a spot hub. This section requires that all metal parts that are likely to become energized, such as metal fences, metal door frames, and metal piping, be bonded together to create an equipotential plane. This will help to reduce the risk of electrical shock in the event of a ground fault. It is also important to ensure that the spot hub is properly protected by a ground fault circuit interrupter, or GFCI. A ground fault circuit interrupter is a device that is designed to detect small amounts of current leakage to ground. If a ground fault is detected, the ground fault circuit interrupter will trip the circuit breaker and to energize the circuit. This will help to protect people from electrical shock. The National Electrical Code requires that all spot hubs be protected by a ground fault circuit interrupter. When installing a spot hub, it is important to follow all of the manufacturer's instructions carefully. The manufacturer's instructions will provide specific information about the installation of the spot hub, including the proper wiring methods, grounding requirements, and bonding requirements. It is also important to ensure that the spot hub is installed in a location that is in accordance with the National Electrical Code. The National Electrical Code specifies the minimum clearances that must be maintained around a spot hub. These clearances are designed to prevent people from coming into contact with energized electrical equipment. In addition to the electrical requirements, there are also plumbing requirements that must be followed when installing a spot hub. The plumbing requirements will vary depending on the type of spot hub that is being installed. It is important to consult with a qualified plumber to ensure that the spot hub is properly plumbed. When installing a spot hub, it is important to take all necessary safety precautions. These precautions include wearing appropriate personal protective equipment such as gloves and safety glasses, and working in a well-ventilated area. It is also important to turn off the power to the circuit before working on any electrical equipment. By following these safety precautions, you can help to prevent accidents and injuries. Here is a summary of the key points to remember when bonding a spot-up motor. Firstly, even if the house has only PVC water piping, the spot-up motor must be bonded to the electrical panel. Secondly, the bonding conductor must be sized in accordance with the National Electrical Code Table 250.122 and be at least 8 American wire gauge copper wire. Thirdly, the bonding conductor must be connected to the spot-hub motor using a bonding lug or other approved method. Fourthly, the bonding conductor must be run to the electrical panel and connected to the grounding bus bar. Fifthly, always check with your local code official to determine the specific requirements in your area. Sixthly, ensure that the spot hub is protected by a ground fault circuit interrupter. Seventhly, follow all of the manufacturer's instructions carefully. Eighthly, maintain the minimum clearances around the spot hub as specified by the National Electrical Code. Ninthly, consult with a qualified plumber to ensure that the spot hub is properly plumbed. Tenthly, take all necessary safety precautions when installing a spot hub. Finally, by following these guidelines, you can ensure that the spot hub is installed safely and in accordance with all applicable codes and regulations. In addition to the above information, it's also crucial to understand the role of the equipment grounding conductor, or EG. This conductor is a critical part of the grounding system and plays a vital role in safely carrying fault current back to the source in the event of an electrical fault. The equipment grounding conductor is typically a copper or aluminum wire that is run along with the circuit conductors. It is connected to the metal parts of electrical equipment such as the spot hub motor and to the grounding bus bar in the electrical panel. When a fault occurs, such as a short circuit between a hot conductor and a metal part of the equipment grounding conductor provides a low impedance path for the fault current to flow back to the source. This high current flow causes the circuit breaker to trip, quickly de-energizing the circuit and preventing electrical shock or fire. The size of the equipment grounding conductor is determined by the size of the circuit conductors. The National Electrical Code Table 250.122 provides the requirements for the minimum size of the equipment grounding conductor based on the overcurrent protection device, such as the circuit breaker or fuse protecting the circuit. It is essential to use the correct size equipment grounding conductor to ensure that it can safely carry the fault current. In addition to the equipment grounding conductor, the National Electrical Code also requires the use of bonding jumpers in certain situations. A bonding jumper is a short length of conductor that is used to connect different metal parts of the electrical system together. Bonding jumpers are used to ensure that all metal parts are at the same electrical potential, which helps to reduce the risk of electrical shock. For example, a bonding jumper may be required to connect the metal frame of a spot hub to the equipment grounding conductor. This will ensure that the frame of the spot hub is at the same electrical potential as the equipment grounding conductor, which will help to protect people from electrical shock if they come into contact with the frame of the spot hub. The National Electrical Code provides detailed requirements for the installation of bonding jumpers. It is important to follow these requirements carefully to ensure that the bonding jumpers are properly installed. Another important consideration is the type of wiring method used for the spot hub circuit. The National Electrical Code specifies the acceptable wiring methods for different types of installations. For example, the National Electrical Code may require the use of rigid metal conduit, or RMC, or electrical metallic tubing, or IMT, for the spot hub circuit. These wiring methods provide a high degree of mechanical protection for the conductors and help to prevent damage that could lead to electrical faults. It is important to select a wiring method that is appropriate for the specific installation and that meets the requirements of the National Electrical Code. In addition to the wiring method, it is also important to select the correct type of conductors for the spot hub circuit. The conductors must be rated for the voltage and current of the circuit, and they must be suitable for the environment in which they will be installed. For example, the conductors may need to be rated for wet locations if the spot hub is located outdoors. It is important to consult with a qualified electrician to ensure that the correct type of conductors are selected. Proper labeling of the electrical panel and circuits is also essential for safety. Each circuit breaker in the electrical panel should be clearly labeled to indicate the equipment that it serves. This will help to prevent confusion and make it easier to identify the correct circuit breaker in the event of a problem. The National Electrical Code requires that all electrical panels be properly labeled. Regular inspections and maintenance of the spot hub electrical system are also important. The electrical system should be inspected periodically for any signs of damage or wear. Any damaged or worn component should be replaced immediately. It is also important to test the ground fault circuit interrupter regularly to ensure that it is functioning properly. The ground fault circuit interrupter should be tested at least once a month. If the ground fault circuit interrupter fails to trip when tested, it should be replaced immediately. Finally, it is always a good idea to consult with a qualified electrician before performing any electrical work on a spot hub. A qualified electrician will have the knowledge and experience to ensure that the work is done safely and in accordance with all applicable codes and regulations. Trying to perform electrical work without the proper training and experience can be dangerous and can lead to serious injuries.